And here we are on the flip side of the 2024 10A and 12A. Inevitably, everybody always asks in the comments, do you think this score is safe? Do you think that score is safe? What do you think the cutoff predictions will be? I might make a separate video for that this year, although it's about midnight here right now, and I'm probably not going to make one anytime soon. I need to film all the solutions that I can before 5 in the morning and get them edited and all of that. So I'm just going to say it right here. If you see people talking in the comments like, what do you think the cutoff will be, please direct them to this video. It will save me time having to respond to them, although I do try to respond to everyone when I get a chance as time permits. I felt the test was harder than last year. So I think you're looking at approximate 2022 cutoffs would be a good guess. Especially on the AMC 12, it felt particularly tricky on several questions with multiple new concepts in the first 12 and very sillyable things that I felt could easily end up with mistake answers or trap answers. And they put those trap answers there. I did observe them. On my AMC 10 test solve, when I was solving it just to see how it felt to me and based on what I've noticed in the past, it felt a little bashy in the early part, like the first 10. I was spending a lot of time to be sure that I was right. And I think I was around question 13. I had spent 30 minutes. That's quite a bit for me. That's more than 2 minutes per question. So that's usually very rare that I would do that because your average on the whole test is 3 minutes. So because it was taking so much time to be certain of my answers and not make mistakes, it feels like you're going to have a little bit lower cutoff than last year, at least as far as the difficulty goes. What do I think are safe scores for both tests? Meaning if you scored this, you're safe, but the cutoff's probably lower. And as you go down with that, what you got, if it's lower than what I'm saying is a safe score, then you're getting into coin flip territory and percentage-based guesses about what it might be. So my guess for a safe score on the 10A would be a 103.5. That would be that you answered 16 questions, you got 15 right, and you had 9 skips. That would be exactly 103.5. And do I think it's going to be that high? No, I think it'll probably be a little bit lower. 100.5 is probably closer, maybe 99, maybe 96, right? It wouldn't surprise me if it's below 100. It just felt there was a lot of bashy problems, and if you were in a hurry trying to get to your USA JMO qual, there's a good chance you might have been tripped up on several of them. For the AMC 12, there was a lot of new concepts and new development of concepts. Very tricky type things that you could get wrong. There was a vector problem, and we'll get to my solution on that in a little bit. Vector sums has not appeared on AMC 12. That's great. It's novel. This is what the test is known for. It pushes the community in a new direction. It's not always what's happened in the past. So even though you knew everything that happened in the past and you were all good at it, they're going to put new things that no one has seen on the test before. And maybe vector sums has appeared. I don't recall it at all. Maybe in the final 5, maybe there was problems that could use vector sums, but early 1 through 10 problem with a vector sum, kind of a new deal. So that was one that was a little bit tricky. Several other ones in the AMC 12 were tricky. So what do I think is the safe score? I think 11 right and 14 skips, and you're probably in. That's a score of 87. So 11 times 6, 66, and 14 and half of 14, 21, 66 and 21 being 87. Could it be lower than that? Sure. Yeah, I think it'll be safe. And could I be wrong? Absolutely. I'm not some guru that knows everything about what's going to be on the test and exactly where it's at. I have a lot of experience at this, and I feel like that will be a safe score, but I would not be surprised if I'm wrong and it's a little bit higher, 88.5, or I don't know if you can get that score or not off the top of my head. But yeah, something like that wouldn't surprise me at all. So having said that, let's get into some of these solution processes. If you have questions, leave them down below. I or somebody else who's being really nice might help answer your question as well. I'm going to get a ton of comments over the next few days. And I will try to respond when I can. I still am working full time. I still have things to do in my personal life like grocery shopping and cooking and things like that all of you or your parents have to do for you. So I won't be able to get every solution out, but I will get as many out as I can. Hopefully 1 to 15 on both tests will be ready in the morning. Let's see how it goes. Let's get started. So 2024 AMC 10A problem 1, 12A problem 1. Same problem on both tests. What is the value of this? Right away, it's a little bit looking bashy, and I spent about 45 seconds thinking about what the best possible approach would be. In which case, people who just bashed it, and you know what, I'm just gonna multiply it. Maybe they got done the same time as me, maybe it didn't take them that long, but I think they made it on that way on purpose. So what am I looking at when I look in here? And this just comes from experience and having seen a lot of these little basic calculation type problems they start the test with a lot of times. I'm looking at a 99 and I think about how if I added 99, I would be at 10,000. That seems peculiar to me. So I'm gonna go ahead and explore that is what I said. And I'm gonna do 101 times 10,000 minus 99. Am I gonna distribute right now? No, why would I do that? Let's keep going over here and notice that I've got, in this one you might call it 100 minus 1. You might also call it 99 times 10,000 plus 101. 10,000 plus 101, because now you've got this 10,000 here. It gets a little bit interesting. In fact, I'll do 101 times 10,000 minus 99 times 10,000 right now. That would be 2 times 10,000 or 20,000. Okay, but I'm going to leave it actually as just the 2 times 10,000. A lot of times there's a benefit to not multiplying things out on the test. People who leave things in factored form tend to, in my opinion, find a lot of solve process shortcuts that they can save time on versus those who were trained to immediately calculate everything that they see. So now we're going to have minus 101 times 99, and then we're going to have what? We also have minus 99 times 101, a duplicate copy. And since this is going to be the same thing as that, and this the same thing as that, we can just put it as times 2. In fact, let's just put the 2 outside right now. You should be able to see all of that. You don't have to write the 2 here. Good and trained students who have done a lot of contest math are quick to observe. They're probably going to factor that out. Furthermore, what do you have here on the inside? You're going to have 2 times 10,000 minus, what is this? It's the difference of squares, right? And so you're going to have 100 plus 1 times 100 minus 1, like that, and that's going to go this way. So now I'm going to have, what's 100 times 100? Looks an awful lot like this. It's going to have 4 zeros and a 1 in front, and you're going to be subtracting it. So over here you're going to have the difference of squares, 100 squared minus 1 squared. And so this 100 squared minus 100 squared, poof, it's gone. That's no problem anymore. Minus a negative 1 squared is 1. 2 times 1 is a answer 2. Did you have to do it with such fancy smancy little tricks and techniques to make it all cutesy? No, you can just bash it out. And that's one of the things about the test. It's accessible to those who might not have a lot of experience yet. And I don't think you're losing that much time to somebody who does this. Although I can do this entire process in under a minute, you can probably bash it in a minute and a half to 2. Maybe you're losing 30 seconds to a minute. But how much time does it take you to perceive that? And then when you capitalize on it, you know, and you're being super careful with your bash method as well, you don't want to make a mistake. It's pretty close to a wash. This is just kind of a neat way to do it, in my opinion, and it is perceptive. How many of you solved this problem in the same factorization technique? Go ahead and leave me a comment down below. Let's get to problem 2. And continuing on with our rapid fire of both AMC 10A and 12A, problem 2, they were once again the exact same question. This was a very wordy problem. If you decided to skip it initially just because you're like, that's a long paragraph, I don't want to do it right now, I know it's going to give me anxiety, probably not a bad call. You can always come back to it later. You're not like giving up on it. It's just like, you know what, just not right now, I'll do it later. Totally fine if you made that judgment call. I would not be surprised if a few of you told me that you did exactly that. But let's go through it. I didn't skip it in particular. My test solve, I just did it, and it didn't take too long, but it does take quite a bit of mental processing to understand what all they're saying with all these words, and you're worried about missing something. A model used to estimate the time it will take to hike to the top of a mountain on a trail is of this form. where A and B are constants. Kind of look and compare to your equation as you're going to process. T, capital T, is the time in minutes, just in case they change it to something later. L is the length of the trail, that's this L, capital L, in miles, and G is the altitude gain in feet. Okay, great, all that's there. The model estimates that it will take 69 minutes, so that's going to be your T here. You're going to write 69 equals. To hike to the top if a trail is 1.5 miles long, so we're going to have 1.5A plus and ascends 800 feet. So 800 is the G, that's your gain, and 800B. Okay, then in turn it says as well as if, meaning the same amount of time, as well as if a trail is 1.2 miles long, so 1.2A, and ascends 1,100 feet. So you're going to have plus 1,100B. Now again, this is just the way I solved it. You maybe did it a different way. There's probably various little shortcut paths you can take. Probably a lot of fun you can have with this problem as far as your methodology goes. How many minutes does the model estimate it will take to hike to the top if the trail is, so you're looking for the T value for 4.2A and 4.2 miles long and descends 4,000 feet. So your final answer is going to be this T value, but you won't be able to get it without A and B, and that's what this is for. Now, I don't want to multiply by 10 because I don't want to, but maybe you did. I'm going to think that I could multiply this by 3 if I wanted, but that one's probably, I'm going to multiply it by 5. And so since that one's times 5, I'm going to do this one times 4, not just 2. I'm not just going to double it up to 3. So times 4 is going to give me 4 times 69. Remember what we said, we don't calculate. In fact, the thought of that's not very nice, just instant calculation, again, tells you just leave it. Don't do anything with it. So you're going to get this is equal to 6A plus 3,200B. Okay, then over on this one, if I multiply it by 5, I'm going to get 5 times 69. It's this 69 with this equation over here, because it's also equal to it, is equal to 6A plus 1,100B times 5 is going to be 5,500B. Now the plan here is to cancel out the 6A's. That's also why we chose something that would give a least common multiple and generate a way to do a cancellation. We're doing linear combinations as opposed to substitution. So now I'm going to take this and subtract this. So I'm going to get 69, 1 times 69 equals, the 6A's cancel, and I'm going to get 2,300B. Immediately divide by 23 times 100. This goes in 3 times, and you've got a value for B. Now, it should be no hesitation from this point to drop it into one of these. I put it into this one. So the 100 in the denominator of B is going to cancel those 2 zeros, and you're going to get 69 equals 1.2A plus 33. 11 times the 3 up here after your cancellation. So now, how far does 33 have to go to get here? It's 30 plus 6, it's 36. So 360 equals 12A. Notice that as you're working, once you've kind of adjusted the competition level, you do things in your head a lot. Yes, you're opening the door for a mistake, but it does allow you to think a little bit quicker, knowing that I would rather do it with integers than a decimal. I mean, many of you that are probably better than me just did it straight up, no problem, and that's great. I like to see the integers, and I knew I didn't want to keep the 1.2a, so now I am going to multiply by 10, and so I get the 36 that I would get from subtracting times 10, the 12. You're going to divide, you quickly get a is 30. So when I put the 30 here, I'm going to distribute the 10 first to get 42, and then the 3, breaking that a up into a 3 times 10. So 3 times 42 is 126. That's 3 times 40 plus 2. 120 plus 6. That's how you get that quicker. And the B, don't forget, we're knocking off 2 zeros because we've got 2 zeros down here to knock off. 3 times 40 is 120. You're going to get 246. That's going to be answer choice B. kind of fun little calculations if you like that kind of thing. Let's get to problem 3 for each of these. Continuing on to the 10A problem 4, the 12A, it was problem 3. Same problem on both tests. The number 2024 is written as the sum of not necessarily distinct, so they could be the same, 2-digit numbers. What is the least number of 2-digit numbers needed to write this sum, the sum being 2024? I mean, since you can use duplicates, you probably want to use very large 2-digit numbers like, say, 99. And 99 is less than 100, and it would take 20 times 100 just to get to 2,000, which isn't even here. So if I did 20 times 99, I would be 20 short of 2,000, or 1980. Then how far do you have to go? 44 to get to 2024, which is just another 2-digit number, and you can do it with 21. You want to be really sure you can't hit this, so just checking, okay, yep, that's definitely less. There's no way, this is a 3-digit number, so if that's not going to do it, there's no way 22-digit numbers could. You can be very satisfied here. Again, check what is the objective, the least number. So 21 is as low as it gets. Let's get to problem 5 or problem 4. The final problem of the 10A, first 5, rapid fire. It's problem 4 in the 12A. It's interesting, if you watch my last day advice video and you happen to read the comments, somebody gave the prime factorization of 2024. In fact, I should have mentioned it in the video. The AMC committee, as tradition, a lot of times will include a problem that uses or utilizes the prime factorization of the current year. They do little Easter eggs like that. So it should have been something I mentioned or thought of, but I hadn't seen it in a little while, and I didn't really think of I didn't think to mention it. I forgot to. So if you're reading comments and you caught that, great. Some of you were like, I wish I had seen this video, the advice video, before I took the test. That's what notifications are for. Go turn them on and subscribe already if you haven't. Okay. What is the least value of n such that n factorial is a multiple of 2024? There's not much you can do with this, and you're like, how am I going to know if it's a multiple? I mean, is it 11 factorial is the smallest one on here. How would I know if it's a multiple? And you kind of think about that for a second, at least for me, like, what's my strategy going to be? And I thought, well, I'm not sure, but maybe prime factoring will help. A lot of times there's instincts that kick in, and there's not a whole lot you can do with any of this. You could try the answers out one at a time, but it seems like, I don't know, to get the idea, you might want to prime factor and see what the problem looks like once you've done that. Now, if you had it memorized, like the student down in the comments did, thank you to that student for mentioning it. That was awesome of you. Then you could just state what it is. But it's not that hard to generate pretty quickly, right? Do we know that 2 goes in? Sure, but you don't want to do it that way. What you're going to want to do is say, does 4 go in? Does 8 go in? 8 goes into 2,000. It's 8 times 250, and that's 8 times 3. So you're going to have 8 times 250 plus 3, and of course that's 253. That's not a good looking 3. Now, because 2 plus 3 is equal to 5, the number in the middle, you can recognize this number at a glance as 11 times 23. That is the 11's trick for multiplying 2-digit numbers. If you did not know, anytime 11 is multiplied by a 2-digit number, you can add those numbers, put the result in the middle, and that's what it will be. Now, if you happen to go over, like, say, 86, you're going to go over 10 when you add, you'll write the 6 here. 8 plus 6 equals 14. The 4 will still go in the middle, but the 1 is going to go with the 8 and bump it up to a 9. And that's how you would do it for that one. But this is the easiest one to spot. Outside numbers, when you add them and they make the middle number, automatically it's 11 times those outside numbers. So you have 11 times 23 times 2 to the third. I would shout out the commenter's name on there, but I'm not sure they want their name shouted out, so I will not do that, at least their handle on YouTube. So now what? You have this product. What are you going to do with it? I mean, it's a good instinct. Then what? All right, so now read it again with that in mind, because you've generated a significant conclusion, a new piece of information. Now that you have it, reread it. What is the value of n such that this n factorial is a multiple of this? Well, then this would need to divide n factorial. If this is going to divide n factorial, 23 is going to have to be a factor. And you're going to get a bunch of evens, so you're guaranteed those 2's. 11 is less than 23. The answer is D. And I don't know, you might have immediately thought of it as, oh, I need to be able to divide this in. Great. To me, I didn't see that at the moment. I didn't think of it that way, even though it's kind of obvious, and many of you probably did. So I just kind of had an instinct, I probably need to prime factor this to think about it, created this, and then said, now what? And now it goes, oh, yeah, now I can see it. If this is a multiple of that number, I'm going to have to divide this in. Therefore, 20, you can't get 23 any other way. It's prime. So 11 factorial, 21, 22, those won't do it. There's no 23s. And that's why the answer is D. Let's get to the next rapid fire if you're on AMC 10, but we'll get to problem 5 if you're on AMC 12. And continuing on with 12A problem 5, the final one of this rapid fire set. A data set containing 20 numbers, some of which are 6, has average or mean 45. When all the 6's are removed, we don't even know how many, maybe we should give it a variable like x. Okay, then if there's 6 plus 6 plus 6 and there's 3, it'd be 3 times 6, so we would have 6x as the total value of all those 6's. Then I'd have to add, if there was x that were 6 and there were some that were not x, the other ones, there'd be 20 minus x of those. Now see what it says. When all the 6's are removed, the data set has mean 66. Now think about how mean works. It's the sum subscript n over n equals the average subscript n of those things. So if this is 66 and I multiply it by the number of terms, I'm going to get the sum of those terms. Therefore, if I take all these terms, which is the number of other terms, times their average of 66, that's going to be the sum of the other terms that are not 6's. And then I could do what? Divide all of this by how many terms? All 20, and the result needs to equal 45. Okay, now, how many 6's, or for us, what's the value of x, were in the original set? So this is a great problem to again illustrate why you don't want to calculate things. You just put them as products and stuff. Let's see what I'm talking about. So I'm going to have 6x plus 20 times 66 minus 66x equals 20 times 45. Again, do I know how to calculate these? Yes, I do. Do I want to? No. Generally speaking, you don't. So I've got 6x minus 66x is negative 60x, which I'm going to move over to this side to get 60x. On this side, I'm going to have 20 times 66 minus 20 times 45 is 20 times 21. So then you'll divide by 60, but over here you'll write that as 20 times 3, and 3 goes into 21 7 times. So x will equal 7, and that's answer choice D. Let's get to the next set.